This is an overview of our work where we investigate the question, do language models have coherent mental models of everyday things? The idea of mental models is not new. Many years ago, it has been proposed that thinking itself is the manipulation of internal representations of the world. Coherent mental models have been seen as crucial to the processes that underlie human reasoning. However, their role, coherence, and even existence in language models have not been systematically explored. In this work, we try to bridge this gap by proposing a benchmark dataset and methodology to compare human internal representations of everyday things with those of language models. We focus on mental models in the context of ordinary objects that we encounter in our everyday lives, like an egg, a tree, or bicycle. We compiled a list of everyday objects and asked human subjects to sketch a mental model for each of them in the form of a graph. In such graphs, each node represents a part of the object, and each edge shows a relationship that holds between the two parts. As an example, here the person annotated for an egg that there is a shell which surrounds the egg white. The egg white then surrounds the yolk. We collect such annotations and created a benchmark dataset on parts and relations of everyday things called the Pericon dataset. It comprises 300 mental models across 100 everyday things, covering over 2,000 parts and over 11,000 relationships. Then we want to know, do language models have similar coherent picture of such everyday things? To do so, we query a language model with a large number of true or false queries. For instance, we ask, judge whether this statement is true or false. In an egg, the shell surrounds the yolk. Then, based on the language model's answers to these queries, we assemble the language model's picture of what an egg is. In this case, we get this pretty confused picture of what it thinks the structure of an egg is. As you can see, there are some obvious contradictions. For example, you can't surround things in both directions. And if you were to sketch this, you will end up with something quite crazy looking like this. We experimented with state-of-the-art language models like GPT-3 and Macaw. Our results show that mental models derived using these language models' predictions are significantly inconsistent, with 19% to 43% conditional violation. And compared to gold mental models in our para dataset, the language model's predictions are only 54 to 59% accurate. This is actually barely better than the majority class baseline at 59% and random chance at 50%. We then asked, can we go one step further and improve things? To this end, we proposed Pericon, a neurosymbolic method that applies constraint reasoning on top of raw language model predictions as a way of obtaining more consistent and more accurate mental models. Here, the input to the system is an entity and list of parts. The first component involves sending an exhaustive list of relation queries to a language model, querying for relations between each pair of parts, out of which we get a mental model of the object, which, as you can see here, is somewhat an incoherent picture. The second component, constraint reasoning, then applies a reasoning layer on top of these raw predictions by using common sense constraints about the relationships. For example, that surrounds is an asymmetric relationship, so you can't have surrounds going both ways. The result then is a more coherent mental picture of the object. In fact, Pericon produces perfectly consistent mental models for all language models with respect to the imposed constraints. So percentage conditional violation in this table becomes 0 for all the columns. And it also improves mental model accuracy significantly by 16 to 20%. One important thing to note here is that the architecture in Pericon is not just the language model, but a system that is a combination of a language model together with a reasoning layer that sits on top and tries to pull the pieces together in a coherent fashion. This approach suggests a broader cognitive architecture that is with a language model together with a reasoner for future systems to create better mental models that are more coherent than just using the language model alone. For more details, we invite you to check out our ACL paper.